Dear participants, we will start our next session. Next session will be handled by Dr. R. Dhanlakshmi ma'am. Her topic is Research Challenges and Opportunities in Healthcare Analytics. Dr. R. Dhanlakshmi is currently working as an associate professor in the Department of Computer Science and Engineering at Indian Institute of Information Technology, Tiruchirappalli. She has a total of 21 plus years of experience, which includes both industrial and teaching experience. She worked in the R&D division of companies such as G-Link, IBM, Cisco, and HCL Technologies. Her research interests include data analytics, combinatorial optimization techniques, and computer networks. We welcome you, ma'am.
Yes. Let me share my session screen. Is the screen is visible?
Yes, ma'am, it is visible, ma'am.
Okay. Okay, so today in this session, we are going to discuss about the recent trends and challenges in healthcare analytics. Okay, this session is handled by two people. One is me and the other one is my research scholar, Mr. Balakrishnan, who is working in that same area. Okay, so the agenda for today's session is we'll start with what is an healthcare analytics, and we are going to discuss about what are the trends and challenges and opportunities, and what is predictive analytics, and what are all the algorithms involved in this. And then finally, we are going to end with a demo. Okay, so I'll be dealing with healthcare analytics, trends and challenges, opportunities, and my scholar will be taking the algorithms related to it, and he'll be explaining the demo also in detail. Okay, first, is my voice is clear?
Yes, ma'am, your voice is clear, ma'am.
Okay, thank you, ma'am. Okay, so first we'll start with what is healthcare analytics. Okay, so the definition for this is it's processing and analyzing the data in the healthcare sector to gain insight, and it improves the decision making process also. So all these things are happening through key areas such as medical costs, clinical data, consumer behavior, pharmaceuticals, macro and micro level healthcare data analytics. All these things, right, can be used for all these areas like medical cost, clinical data. For all these areas, this micro level healthcare data analytics, right, it is used to effectively streamline the process, optimize the patient care, and finally it reduces the overall cost. Okay, so healthcare data nowadays is the most dynamic in all fields. It includes the electronic healthcare records and real-time recording of vital signs. Okay, so here in healthcare analytics, the data, right, comes from multiple sources, but one must conform with government regulations also. Okay, so it is a complicated and complex operation which requires a level of protection and accessibility that can only be supported by an embedded analytics system. So nowadays, right, the situation has come to a level in such a way that the doctors, right, are viewing the patients through the mobile or through the laptop, and they are discussing with the patients, and they are advising the prescriptions. Okay, so for all these things, we should have a well-defined system which records everything, and it should be a secured one also. Okay, so the role of data analytics, it plays a major role in the healthcare system. Okay, so here whether we need to improve the quality or manage the risk or anything in between, we have to access a large ton of data. However, just having the data alone won't do you do much good if you don't have a systemized way to organize, analyze, and interpret data. Okay, so this is one of the reason why data analytics is so important in healthcare. By using analytics techniques, you not only make the sense of the past, but also you can chart out the course for the future, for the benefit of the entire healthcare community. Okay, so coming to the types of healthcare analytics, there are basically there are four broad classification. It is given here, such as descriptive analytics, predictive analytics, prescriptive, and discovery analytics. These are the four broad classification of healthcare analytics. Okay, so descriptive analytics, what it does is it explains what has happened in the past. Okay, so here with the past data, we can analyze and we can fine tune few things. But when we come to the predictive analytics, okay, it predicts what is likely to happen next. Okay, so it analyzes the past data and it tells it suggests what is likely to happen next. Okay, and the third type is called as a prescriptive analytics. Okay. So here it uses the machine learning algorithm to suggest a course of action. Okay. So if it tells what will be the effects if we take some action. Okay. If we move, if we prescribe one particular drug, what will happen? Or if we prescribe the other drug, what will happen? Okay. All the effects, everything is clearly explained with the help of a prescriptive analytics. Okay, and the last type is the discovery analytics. It says, what do we need to explore further? Okay, so it uses the machine learning algorithms to analyze the raw data and determines the interconnections, patterns, and it finds an outline. Okay, so it explains what further we need to explore. All these things can be done with the help of a discovery analytics. Okay. And when we come to the key uses of healthcare analytics, so here data analytics, right? As I said, it can help to improve the healthcare for all the industry stakeholders, from health systems and from physicians to patients, pharmaceutical and medical device companies, and specialty societies. Okay, so the use of big data analytics in healthcare can be broadly organized in four main buckets. Okay, so this healthcare analytics can help your organization to enhance its competitive positions, to improve the quality, to advance the research initiatives, and to manage risk and reporting. Okay, so to tap into these key uses of healthcare analytics, you need a cutting edge software and a trusted process to take you from an unmanageable jumble of data to an actionable real world evidence. Okay, so for all these process, there are set of tasks which we need to handle it. So the first one is the acquiring the data. Okay, so it plays a major role. Whether you use a machine to machine data transfer or patient surveys, or you can extract the data from the nurses through the case files, or it can be of any of the things, but all data needs to be collected in one place. So acquiring the data plays a major role. Once the data is acquired, then you have to transform the data. That means you need to ensure that the data is cleaned, validated, and analyzed to answer the research questions. And the last thing comes into acting on the analytical insights. Okay, so this leverages the real world evidence to reach your organizational goals. So in addition, you will need to make sure that your data analytics software solution is flexible enough to evolve with your needs, and that it's built with high level security features in place. In that way, you'll have everything you need to unlock the greatest possible value from your data. Okay, so the key uses is, first you have to understand the performance, and you can improve the quality by various measures listed here. And advanced research is going on, and you can prevent the risk also by having a proper healthcare analytics system. Okay, so coming to key benefits of using analytics in healthcare. Okay, so first, right, it improves the patient care. Okay, so the significant benefit from the knowledge derived from the big data analytics, right, delivers greater clinical insights to various healthcare providers. So these cutting edge analytics improves the patient care in the healthcare system, as this data facilitates doctors to prescribe the effective treatment and make clinical decisions more accurate, further eliminating any ambiguity involved in the treatment. So in this way, it improves the patient's health care. Okay, and then based on this, right, the next benefit is it predicts the patients who are at higher risk, and the patients who are at higher risk, right, has to be have to be addressed immediately. So the healthcare analytics system, right, rises an alarm and it sends I mean, it sends an intimation to the treating doctor so that they can attend the patients immediately. Okay, so and the next benefit is it eases the patient diagnostics with electronic healthcare records. Nowadays, right, if you are moving from one hospital to another hospital, right, you are forced to repeat all the tests again and again. So, with the help of a proper analytics system, right, you can take the test at one place and the same thing can be used at multiple places. Now the government is going to implement such type of things across the hospital. Okay, and it ensures, so if we make this right, it reduces the overall cost which is involved, which is being spent by the patients in the hospitals. Okay, so it delivers greater insight into patient cohorts. Cohorts means it represents the groups, and it enables the improved healthcare with fitness devices. Now every one of us, right, it's having a watch which tracks how much distance we have walked in a day and what is the BP and what is the fitness level can be easily measured. Now most of us have are using those devices. Okay, and the final thing what is given here is all these things, right, with the help of an proper system, with the proper alerting things, right, we can save the patients immediately. Okay, and then coming to the top reasons why healthcare industry is moving towards analytics. Okay, so there is a proverb that prevention is better than cure. Okay, if you see in today's health conscious environment, the awareness among the general public on fitness and well-being is increasing. We all have to accept this, because if you see from March till now, every one of us, right, are watching what is happening in the other countries towards this COVID treatments and what type of vaccines are coming up and what is the result. So everyone is watching towards it. Okay, so this has powered the market for devices like wearable tech, as they help the consumers to easily track their health without having to perform regular medical checkup. Okay, a recent study shown that the use of wearable tech helps to grow the patient engagement by allowing them to keep track of their daily routines. So like this, right, similar major companies also are investing to develop their own product through this data analytics. So the healthcare companies, okay, they are adjusting their business plan and include this big data and analytics in the long term growth strategies by leveraging their apps and wearable tech markets to stay in a profit mode. Okay, and then the next reason is facilitates diagnosis. Okay, so this analytics, right, makes it easier to analyze a large volume of healthcare data generated by various devices on an everyday basis, and it ascertained the critical insights about the disorders which would otherwise prove impossible to predict. Okay, in fact, even the doctors, right, will soon be using the analytics to know the complete history of their patients. At a micro level, if we see, admission to a huge amount of national healthcare data will help the government to spot increases and outbursts and develop strategies in advance to cope up. So through this diagnosis methods, right, even if some outbreak comes also, the government, right, can control it. Okay, and the next reason why the healthcare industry is moving towards analytics is to reduce the fraud. Okay, so now we are hearing many things in the newspaper and in the channels also, that many frauds are happening in the healthcare sector. Okay, so the usual frauds, right, can be in any of the form of several treatments being used in the same person's name, patients getting treatment from many hospital instances, simultaneously, etc. Okay, analytics, right, it helps to safeguard the companies in the healthcare industry from such misuse by using a predictive analytics to find out the consistency and patterns. So once these patterns are recognized, right, healthcare players can take a precautionary action and save them save the patients from huge losses. Okay, now here the sector and investment trends are being listed out. Okay, so if I see, if I initially right, the use of AI came into existence. Okay, so the companies right started selling its AI software as a service to healthcare clients or using AI to develop products for the healthcare market. First, it started like this, and then telehealth has been improved, so most of the companies right entered into this mode and they have developed various medical devices. Okay, if you see right, compared to all the countries, digital health in China has been developed in an enormous way. Okay, and if you see in India right, even now the focus on women's health is also a matter of concern. Now because of this corona situations, now we all are forced to stay at home. Okay, and the mental health of the members right, it's being assessed by various company devices in both psychological and emotional way. Okay, and then this regenerative medicine is also coming up. Various companies right involves their thing in the R&D divisions for to develop a regenerative medicine, which involves gene therapy, cell therapies, and bioengineered tissues. So we are hearing all these things in a day-to-day life. Okay, this is in the overall view. Okay, so when we take about the India, okay, so there is a strong demand for the healthcare sectors. There are so many attractive opportunities are there. Okay, so this increases the manpower rise, and the government right is coming up with various policy support in terms of insurance and in terms of schemes. Even this Ayushman Bharat also, it's launched in the year 2018, and the government right, it's coming up with various schemes to address the healthcare sector. Okay, so here, right, the healthcare with respect to the market size, right, from 2016 to 2022, it's 2022, it's given here. So in 2016, the CAGR, so CAGR represents the compound annual growth rate. It's keep on increasing from 140. It is predicted to be increased to 372 by 2022. Okay, so this, since the market size is increasing, the sector composition also right, they are also increasing. The government is also implementing various schemes, and the infrastructure is also it's coming up in all the states. Okay, when we take about the key trends with respect to the health insurance premium, okay, so in 2016 it is taken as 4, and in 2020 it is taken as 7.3539 billion. So this is the amount which is being generated with respect to the insurance. So the government is also coming up with various initiatives through public private partnership, and the national oils mission is also implemented, and the government is coming up with national health policies also. So all these things I've taken it from the report which is present in healthcareindia.aspf. So here the link is given. So from here we have taken all these values. Okay, when we take the healthcare sectors in India, so the major healthcare clusters are present in Mumbai, Delhi, Calcutta, Chennai, Vellore, and Bangalore. So whatever the decisions right taken in the clusters is replicated to all other places. Okay, coming to the healthcare companies, there are various companies, out of which Apollo Hospitals, Thyrocare, Fortis, they have opened their they have opened their concerns in almost all over the places, all over the cities, and whatever they test right they are taking, it is common across all the places. Okay, so they also has in the last one, if we take that last 15 months right, there are many things which has come up with these companies. Okay. When we take the global and regional healthcare IT security market research survey, what it says is the healthcare IT security market, right? It offers a detailed competitive landscape in the global market. Okay, so it includes the company, it includes the market share analysis, product portfolio of the major industry participants. Okay, this report, what it provides a detailed segmentation of the healthcare IT security market based on the product, what is the technology being used, what is the end user, and in which region it is going to be used. Okay, so there are various companies involved in this process, such as IBM, Dell, Trend Micro, Intel, HP, Norton LifeLock, PricewaterhouseCoopers, SailPoint Technologies, Oracle Corporation, CA Technologies, CyberArk, Verizon, CenturyLink, Okta, AT&T, Wipro, and then there are many companies. We have listed out few things. Okay, so the research comprises, right, all these companies, right, they have analyzed and they have found out the requirements of all the products which they are going to develop, and what is the applications and which manufacturer is going to develop it. Okay, so this survey, it supports data related to the organizations regarding the position they acquire, the sales they are going to make. Okay, and this report, right, also endorses the data related to the firm's price models along with the gross margin. Gross margin. Okay, so based on this report, so the healthcare sector, right, almost all the companies, right, they are coming up with their own strategy. Okay, so here again CAGR represents the compound annual growth rate. Okay, so with the help of this predictive analytics, right, they are telling that by 2026 the compound annual growth rate, right, will be increased to will be increased by 28.9 percentage. Okay, and so here the report of Indian healthcare sector, what it says is the report has been taken from medicaldialogues.in. So here what they are telling us, they have compared from 2008 to 2020. They are telling that so the compound annual growth rate, right, it's increased drastically by 17% when we compare from 2008 to 2020. Okay, so these are the various surveys which has been taken by various agencies. Okay, so when we see the top healthcare trends in 2020, okay, so we have to check what is the priority and what is the capability. Okay, so here the improving customer experience. So with respect to this key factor, so when a survey is taken by healthcatalyst.com, okay, they have taken a survey and they were telling that you are to the customer experience need to be improved. So 81% of the people, right, have voted for this. Within on a high priority, this has to be improved. Okay, and 11% of the people have suggested that it should be improved in terms of capabilities also. So they should be the healthcare sectors, right? They should be in a position to handle whatever the patients coming in. Okay, so they should not say that the treatment cannot be done here. You should move from one place to another. So this should not be there. So wherever the patients, right, wherever they go, the treatment should be common across all the sectors. I mean, all the organizations. In one way, I can say like that also. Okay, so then coming to the offering variety of facilities based on access point. So 61 for high priority and 10% they have told that it should be improved with high capabilities also. So like that, utilizing digital tools to engage consumers is given, providing the price transparency, developing an outpatient pricing strategy, offering variety of virtual access point, and using consumer learning to guide strategy, it's given here. Okay, when we take the financial performance, it indicates that from 1999 to 2019 is given, it has been drastically improved. Okay, and then coming to the technology trends, which is going on now in healthcare with respect to 2020, it's given here. So here 8 trends have been listed out. Now telemedicine, it's coming into picture. Okay, so telemedicine means previously, right, for each and every disease, we used to meet the doctors. We have to wait and we have to take the appointment. We have to go, we have to wait, and we have to meet the doctors. Now, with the support of with the increasing demand in the internet technology, right? And now because of this corona situation, okay, so that only helps us to go for this telemedicine concept. Now the patient, right, if they have some symptoms, right, over the phone itself they can take the advice and they can start the treatment. Okay, even the government also has launched a portal, and they have given a toll free numbers. If it is being advertised in the radio as well as in the FMs and in the television also, it is being broadcasted. So if anyone is having a symptoms like mild symptoms, right, they can access the toll free number, and they can take the suggestion. And if they are not well also, if they are being intimated in that number, right, immediately from the GH government hospital, the people are coming and taking the patients for treatment. Now we are seeing all these things in almost all the places. Okay, so now with the advent of internet, right, this medical things has been drastically improved. Okay, now with the improve, I mean with the large saving of data, right, we have to store the data. So the next trend is how to store the data. There the cloud computing plays a major role in healthcare. Okay, so now once if we have a large amount of data, then the next task for the analytics company, right, they should know, they should have a proper plan in place to tell how they are going to store the data and how the doctors, right, are accessing the data. Okay, and then AR, VR, and MR, virtual reality plays a major role in healthcare. Now the artificial intelligence, right, it is being implemented in healthcare. Chatbots, even with chats also, you can access the doctor. And data science and predictive analytics, it's coming up now. And I'm telling the data. So the data, right, if it is stored right, it should be a secured one. Then only the patients will get the right treatment. Okay, so for ensuring the security, this blockchain technology, it's booming up like anything. Okay, so coming to the digital transformations in healthcare in 2020. So 7 key trends are listed out here. Okay, so this research has been taken by Digital Authority concern. Okay, so they report, right, what it suggested. Okay, so 52% of the patients, right, they want an on-demand healthcare, like that they are telling. And here the physicians and hospitals need big data insights. So they have taken a survey and the details are listed out here. And the wearable devices, right, it improves the preventive medicine. And this virtual reality, right, helps the doctors to get better training, and AI makes the personalized treatment possible. So this survey has been taken by Digital Authority partners, and it is listed out here. Okay, so here this report, what it says is we are telling data. So how there are security breaches happening, that also we are hearing in various media. Okay, so if we take 2019, out of 494 cases, only 69 of the security issues have been resolved, whereas 425 is still open. Okay, so the data, right, it's coming from healthcare wearables, smart home technologies, and even at home genetic test. Okay, so these are all these things, right, are creating a large amount of data which need to be synthesized, and everyone, right, wants to get hold of that information. Okay, so the patients, right, are requesting greater access to their medical records to help them make informed decisions about their care. Okay, so providers, right, what they are doing is they want to aggregate the patient data in order to use it in a predictive manner. But unfortunately, the increasing demand for this type of data is attracting the cyber criminals. Okay, so the data breaches, right, it's a problem across all the industries. Okay, so in 2019, right, as I said, 494 cases, right, have been recorded, out of which only 69 are resolved, and still 425, right, are not resolved. Okay, so this security is a matter of concern. Now the companies, right, are focusing on implementing or improving their security policies with respect to data storage and data retrieval. Okay, so here the cost transparency with respect to with respect to the years are given. So here estimated revenue loss. So here, right, once they discharge, right, there are chances of readmitting the patient. So how much revenue loss have been incurred by various countries, right? It's given here. So in 2020, the loss is listed as $591. Okay, whereas in this is the estimated revenue loss due to hospital acquired condition. Okay, so this is the penalty which has been incurred. Okay, so we here this slide represents the various healthcare analytics, how it is grow. I mean, how it is coming up in various countries. Okay, so this report has been taken up from gminsights.com. So what they are telling us. Okay, so here, right, they have listed out Germany, UK, France, Italy, Spain, Russia, and others. By 2025, right, this Germany, right, will come up drastically. This is the prediction what they have made with respect to the countries. Okay, so here the factors, right, so with a country like India, right, the population growth is a matter of concern. So due to this there is an increased economic power, and due to this there is a large expansion of we need to expand the public healthcare system. So that is given here. Okay, so the 5 key elements of smart healthcare communities are given here. So the key elements are empower proactive health and well-being management, foster a sense of community and well-being, enabled by digital technology and behavioral science, meaningfully use data to improve outcomes, enable new and innovative ecosystems. Okay, so there are so many things have been listed out here. Say for example, if I take administrative automation and digitization. Okay, so there are n number of companies which are working in the healthcare sector. All these companies are listed out here. With respect to the administrative automation, this Incredible Health, Notable, Proteiner, Cedar, Olive, Redox, these are the various organizations which are working towards the administrative automation. With respect to the disease management, these are the companies which are working on it. Screening and diagnostics, here I have listed out the various companies which are working on it. So like that, if you take clinical intelligence and enablement, so here the companies like Excel, Sophia, CMR, Nuo, all these companies are working on this. Okay, so online, offline care, primary and urgent care. So these companies are working towards like this. The healthcare sector, right? We are telling healthcare sector, but under that there are so many subdivisions, and there are n number of companies which are working on each and every task. So this report I've taken it from cbinsights.com. Okay, so a category focus has been taken by CB Insights here. This has been taken up in 2020. Okay, so here this survey has been taken, and 17% right of the people right are telling that clinical intelligence and enablement have to be improved. 16% of the people right suggested to improve the screening and diagnostics. 11% of the people right, they were telling that virtual care delivery need to be improved. 10% they have told disease management and therapeutics need to be improved. Like that, online offline care, drug discovery, administrative automation and digitizations, real world evidence, health plans and benefits management, pharma supply chain, online offline care. So all this survey has been taken and it is listed out here. Okay, when you take about the thematics and trends, okay, now telemedicine is coming up drastic, it has been improved drastically. Okay, so the 31% right of the people supported for telemedicine. Okay, but still 6% right, they are asking for a virtual assistant, and they have to, and someone needs to be monitored the patients in a regular basis. And telepharmacy subscriptions, right, it has to be improved. 6% of the people have opted that. And virtual primary care opted by 11% of the people. Therapy and coaching need to be improved by 18%. I mean, this has to be improved. So 18% of the people suggested for therapy and coaching. Okay, so coming to the geographical distributions, so if we take the healthcare providers, right, 77% of the companies, right, are located in US, whereas in China, 4% of the companies are there, and UK it's 3, France 3, Canada 3, and rest others 11%. Okay, so this report is also taken from CB Insights. Okay. Coming to the major challenges of data analytics. Okay, so there are 10 major challenges. One is first challenge is the capturing the data. Okay, so the data, right, must be sourced from a place with an impeccable data governance habit, and it should be clean, complete, well formatted and accurate. Okay, it's a common issue for the data to be skewed moving through elaborative workflows, little understanding of the essence of big data and the whole process. Okay, to solve this, okay, we need providers to fine tune their data capture routines, prioritize the valuable data, hire data governance experts we need, and coach clinicians on how to make the information for analytics is required. So capturing the data is the first challenge. Okay, once the data is captured, next comes the cleaning. Okay, as you all know, say suppose if you are downloading a data set also, right, first, right, the data it can be in any form, and there must be some missing data also or redundant data also. Okay, all these things, right, need to be processed first. It has to be cleaned and it should be in the uniform format. Then only we can give it to the algorithm or give it to the model to predict. Okay, based on the training and testing set, right, we can predict the things. Okay, so the challenges with respect to the data, the first challenge is the capturing the data, and the second challenge is the cleaning the data. Okay, and the third challenge is to how we are going to store the data. Okay, so we are using a cloud storage, as I said. In the cloud also, right, are we using a software as a service, or are we going to own the infrastructure for data storage? All these things comes into picture. Okay, are we going to use a hybrid approach? Okay, all these things comes into a picture. Then the fourth major challenge is the security. So from the beginning, I'm insisting on the security again and again. So those who are working on the data science problems, right, the security is a area where you can explore further. Okay, so there are we should so the data, right, has to be transmitted. It has I mean when it is accessed, right, it has to be authenticated, and it has to pass the integrity and auditing test also. Okay, so we are using many firewalls, all these things, but even then the hackers, right, they are tapping over the data, and there are chances that they may change the data also. So if the data is tampered, right, it may create a huge loss to the society. So the healthcare sectors, right, almost all everyone, right, it's they are focusing on the security aspect. Okay. Then the fifth challenge is the stewardship. Okay. And sixth one is the querying. Querying, what it says is so when we so the data, right, in every device, right, it's coming up and we are storing it. So when we need the data, it should come in a quick. I mean, when we access, when we send a query, right, the result, right, should come properly. Okay, so that querying is the next challenge. And the seventh challenge is the reporting. Okay, so we have tons and tons of data. So we need a proper mechanisms to give the report whenever it is expected from the end users. Okay, and the next challenge is the visualization. So with the help of with the improvement in Python and R, right, there are various visualization tools has come up, and we can explain the what is the trend going on, and to an organization or to the patient group also, right, we can show the trend. If the healthcare sectors, right, if they are developing a product, they can show how it is being implemented and what type of results they have got. So there are various visualization tools which is coming up now, thanks to the Python and R developers, because previously, right, it is very difficult to learn the Java things and all. Now any people, right, who is working in any sectors, right, they can easily adopt to this Python and R, since because of the language is very simple. Okay, and the ninth challenge, right, it's an updating. Updating means you have to update the record. So as and when the data, right, gets updated, right, yeah, it has to be updated in the cloud environment immediately. Okay, so if you are storing multiple times, right, the same data, right, it can lead to duplication of records. So the right data has to be updated properly. And then the last 10th challenge is the sharing of data. Okay, so it is a vital part to share data with external partners, given that the industry is edging towards a health management and value based attention. Okay, so here I can say that there are several impediments to sharing the data, including the data interoperability, how electronic healthcare records are presented, and the way how the clinicians or the doctors, right, how they are understanding them. So all these things are the major challenges with respect to the data analytics in the healthcare industry as of today. So here various sectors and the challenges is given here. So they are telling that financial operations and the performance needs improvement. This personal care model needs innovation. Digital transformation and interoperability needs to be extended. And then aging, due to the aging population and the shortage of the skilled doctors, right? Okay, so they are predicting that there will be an increase in the number of doctors hiring and training and frontline workers. All these things, right, are going to be increased. So this is the prediction. So this things, right, I've taken it from deolite.com. Okay, so here the various supply drivers and demand drivers are taken with respect to the health information and technology. Okay, the supply drivers for this system are the medical patient data. So this data, right, can be stored in the form of electronic health records. It can come from health sensors, social media, and it can come from the genomic sequence. Okay, so all these data, right, I mean, all these data have to be stored properly. Okay, and the next supply drivers is the big data analytics. Okay, so all this data, right, have to be stored, processed, and it has to be accessed properly. And now with the help of this pervasive technology, right, even the data coming from mobile smartphones, all these things, right, have to be stored and retrieved properly. And healthcare professional digital workflow. Okay, so due to the increasing in the concept of telemedicines, right, the data, it's coming from various sources and various means. So these are the supply drivers. When we take the demand drivers, you need to roll out a business model which is tied to the patient outcome. Okay, so this reduces the medical errors and improve the quality. And you need to discover and deliver targeted therapies. Okay, so that the patients life cycle, I mean life will get extended. Okay, and now, right, with see, as we all accept, right, in addition to the tablets whatever the patient is taking, right, if some counseling is given, it is creating a good result. So in various research reviews, right, they are telling that a positive attitude changes the patient's clinical condition. Okay, they are telling like that. And then we need a protocol driven patient risk pool, and we should have a stratification management. So these are the various demand drivers which are being used to in the healthcare technology. Okay, now coming to the predictive analytics. So predictive analytics, right, this, as I said in the first slide, right, it helps us to predict what is going to happen in the future. Okay, so here this predictive analytics, right, I can say that it is being implemented in the government organizations, it is being implemented in the research institutions, mid-sized companies, small business, all these things. When we this is across, it is being used by everyone. When we take the technologies, right, in the government organizations, right, they have implemented this Monte Carlo simulations, linear programming, computational models they have developed. Corporates and research institutions, right, they have come up with non-linear programming and computer based heuristic problem solving. And mid-sized big companies, right, businesses, right, they were working on the analytics systems, and they understood the need of a real-time analytics, and they have come up with the prescriptive analytics also. And small businesses, right, with R and Python, right, they have developed the system. And if you are not storing the cloud, right, we can create a Hadoop environment, and we can store the data with ourselves also. Okay, if you want, we can go for cloud. Okay, so all the sectors, right, it's growing, and the technologies, it's also coming up well. So this data I've taken it from dataflog.com. Okay, so here, right from 1930s to 2020, how the system has been developed and how it has been progressed, it's given here. Okay, in 1940s and 44, right, with a big room-sized computer, they have started working on it, and in 1970s they have understood the use of analytics, and they've started this Amazon, eBay, and all, right. It has come up in 1970s to 1995 or 2000. So this are companies, right, various companies like Amazon, eBay, Google, Flipkart, all these companies, right, they've started their things. And if we take 2000 to present, okay, so this it started with cloud computing, grid computing, and then big data, or AI technologies. Okay, we are quoting various terminologies, but it all meant for the processing the data. Okay, and what they are, I mean, 2000 to present, all these things are there: server farms, big data, cloud, all these things are there now. And what is expected in the future is that is ubiquitous analytics. Okay, and with the help of the technology, right, curing the rare diseases. Okay, so now with the help of this internet and the telemedicine concept, right, a doctor, right, from anywhere can suggest and treat the patients by through the internet facilities. Okay, so this is going to be the future. So there, most of the companies, right, they are investing major funds to improve the healthcare analytics. So that is given here. Okay, here the definition of predictive analytics is given. As I said, it predicts what is going to happen in the future. Okay, when we take the definition, it's a type of technology that combines the machine learning and business intelligence with historical as well as real-time data to make projections about the future events. Okay, so with the help of the predictive analytics, okay, we can have a promising use cases like to capture the data, and from the data, right, we can arrive at meaningful insights. Okay, this in turn improves the patient outcomes, reduces spending, and increases the operational efficiency. Okay. So the purpose of predictive algorithms in healthcare is to find the correlation in the patient's data and what is the mapping with respect to the symptoms, whether the patients, right, whether their forefathers or antecedents, right, whether they have the same symptoms or not, and to explore the genomic structures by analyzing the various factors, and then whether we can also assess whether the past or the current diseases, right, will influence the future problems. So all these things, right, can be solved with the help of a predictive algorithms. Okay, so this predictive analytics, right, it is commonly used in the healthcare sector. It is to, as I said previously, it is to improve the operational efficiency. It increases the personal medicine. It addresses the population health and risk scoring. And as I said previously, it outbreak prediction, and it can control the patient deterioration and the supply chain management wherever is required, right, the proper drugs, right, can be sent to the right people at the right time. And potential in precision medicine, cost reduction from eliminating the waste and frauds, and the security is also a matter of concern here. Okay, so here the opportunities for growth and innovation in healthcare predictive analytics is given here. Okay, so there is a limitation on the index models. Okay, so now, right, there is a site called eGov. So in that, right, we can download the patient's data and we can use it with respect to a specific health system. Okay, so the data availability. So the health system, right, have increasingly more detailed data, and we need a more pervasive analytics, and we need the tools. So there are a lot of opportunities if we focus on this area called predictive analytics. Okay, coming to the challenges of implementing the predictive analytics solutions. Okay, so we need to integrate separate data sources because data is coming from different means, from the cloud, from the systems, or from the wearable devices. Okay, all the data have to be stored and accessed properly, and we should be familiar with the adoption of cloud technologies. Privacy and security, it's a matter of concern. The organizations are coming up with the proper solutions. And with respect to the technology changes, these solutions also need to be changed and updated quickly. So these are the various challenges in implementing the predictive analytics solutions. Okay, so the top three recommendations for implementing the predictive analytics in healthcare is given here. First, right, whichever the organizations, right, whichever it's going for this, they have to understand the analytics environment. They should know, they should familiar with the some group of people, right, should be familiar with the tools and methods which is being used, and the deployment procedure also should be known to them. Okay, so here the largest share with respect to the healthcare analytics market in 2020, it's given here. So here the countries like North America, Europe, Asia Pacific, Latin America, Middle East, and Africa, it's given here. So here the large sector, right, the analytics market, right, since as I said in one of the slide, right, most of the companies, right, are based out of US. So a lot of opportunities are there with respect to the healthcare market. Okay, so here predictions for global healthcare industry it's given. So this whatever we discussed it's summarized here. We need a outcome based things. Yeah, it's coming up. So now entire thing is moved to the digital health. Okay, so there are a lot of rising opportunities. Okay, so the healthcare analytics, right? It shifts from big data to a meaningful small data by hospital specialty. Okay, and here the voice application is also embedded. Blockchain, it's being implemented to increase the security aspects of the data. Okay, and insurance models also, because this is also one of the factor which we need to, which the country has to adopt it. Okay, and here 80% of the healthcare industry, right, believe four technologies, namely AI, big data analytics, health, mobile health, and wearables, which will be a game changer during 2019. They have predicted like that, but in 2020, right, it has been implemented. Okay, so there are various machine learning algorithms used in the medical literature. So if you take any literature with respect to the data science, right, you can see that support vector machine, neural network, logistic regression, discriminant analysis, random forest, linear regression, Bayes, nearest neighbor, decision tree, Hidomorphan, and others. Okay, so these are the main things. Out of this, right, the support vector machines plays a major role. Okay, support vector machines plays a major role here. So there are n number of algorithms. Depending on your requirement, you should take your algorithm. Okay, so here, so this paper, this slide, right, shows that how the algorithms are scattered. Okay, this data, right, it's taken from the PubMedia. Okay, so in almost all the things, right, support vector machine, right, this algorithm plays a major implications when we compare with the other machine learning algorithms. Okay, so that's all with respect to the introduction. Now I request Mr. Balakrishnan to start with the algorithms.
Yes, ma'am.
I will stop my sharing.
Sure.
You can share your presentation now.
Okay, ma'am. Thank you. Yes, ma'am. Am I audible, ma'am?
Yes, proceed.
Yes, ma'am. Let me start with a brief introduction about the machine learning and its types, followed by the demo. Okay. The standard definition of machine learning is the field of study that gives you computers the capabilities to learn without being explicitly programmed. We doesn't have, we don't want to program, okay, explicitly for a particular problem. Okay. In machine learning, what they are going to do, they are going to take a study of algorithm that improves the performance at some task based on some experience. Okay, simply we can say machine learning is equal to, okay, experience into task is equal to performance. Experience in the sense, okay, we are having the data, okay, whatever the input data we are having, that is the experience. Okay, based on the experience we have collected the data. And the second one is task. Based on the input data we are going to perform the task. What are the tasks we are going to perform, whether we are going to predict something, whether we are going to deduct something. Okay, that kind of the things are considered as a task. Then finally, how we are going to measure the how we are going to measure our algorithm based on the performance. Okay, these are the things we are going to do with machine learning. Okay, in machine learning, there are three different types of machine learning. The first one is supervised learning, the second one is unsupervised learning, and the third one is reinforcement learning. As the figure indicates, the supervised learning, okay, there is the supervision is there. Here we will be having a label data, both the input data as well as the output data, both the data will be having a label. Okay, whereas in unsupervised learning, okay, here you will be having no supervision. Okay, based on your input, okay, you need to perform it. Okay, as the figure indicates, the child is doing the calculation, okay, without any supervision. And the last one is the reinforcement learning. The basic idea behind the reinforcement learning is, okay, you need to start with an agent. Okay, this figure is an agent. Agent needs to start, okay, learning from their environment. Whatever the environment it is given to the agent, it needs to start working on it. Okay, it will learn, okay, by doing some actions. Okay, that action indicates, okay, whether the agent is doing correct or not. If it is doing correct, okay, then it will be considered as a reward. If it is doing anything wrong, okay, in that matter we can say it will get a punishment. Okay, these are the three different types of machine learning. Next, these are some of the parameters we are going to discuss in detail. Okay, the first one is the definition. Okay, the definition of supervised learning, okay, is a type of machine learning wherein which we teach the machine using the labeled data. So an input and output, okay, both the data, input data as well as output data, both should be in label. Okay, label data. The next one is the unsupervised learning. Okay, the data is provided in the machine is not a label data. Okay, you need to clear that. Okay, the first one, supervised, is a label data, both the input and output. Here in terms in supervised learning, okay, there is no label data. Okay, and the machine has to learn without any supervision. So that's why it should discover some hidden patterns and trends in the data. Okay, it will find some hidden patterns and trends the data. Finally, we have a reinforcement learning. Here, the basic concept behind it is the agent, totally the agent. Agents plays a vital role here. Okay, based on the interaction between the environment, okay, it will get the rewards as well as punishments. Okay. The next parameter we have to consider is the type of the problem. Okay, using the supervised, unsupervised, and reinforcement learning. Under the supervised learning, we have two main categories. The first one is a regression problem, and the second one is the classification problem. Classification about predicting the label or a class, whereas in regression is in predicting the continuous values or continuous quantity. Let's say you have to classify your email into two different rules. Here we have classifying our email into spam and not spam. Okay, let us consider the email, the classification is spam or not spam. Okay, we have to assign, okay, first initial time we have to assign our data into two different classes. Okay, the spam and not spam, based on the keywords. For example, okay, the offer, okay, a bonus, okay, these are the some of the keywords we will be giving into not spam. Okay, some of the keywords, okay, urgent, okay, you have to these some keywords we will be giving as an spam. Okay, these are something we need to set, okay, for classifying spam mail and not spam mail. Okay, and we may use the classification algorithm. On the other hand, the regression one, okay, it's purely based on the continuous variable. Okay, the graph indicates based on the continuous variable. Okay, is an infinite number of possibilities. Okay, you will be having infinite number of possibilities, whereas you can say dependent variable. Based on the dependent variable and independent variable, we will be predicting something. Okay, we can do that kind of task in the regression problems. Okay, For example, the person's weights. Okay, someone could be 180 pounds, someone could be 110 pounds, someone could be 108.5 pounds. Okay, it may be vary. Okay, now the number of possibilities of a weight is differs. Okay, if someone should be okay, for example, I'm having a 60 pounds, the height will be like that. Okay, we can predict something. Okay, like that. Those kind of things we can do here. Then again, one more example. Let us say the prediction of stock of the product over the period of time. Okay, over the period of time, for example, August 2019 to August 2020. Okay, what are the products, okay, rolled out well. Okay, we can predict all those things. Okay, that can be done using the regression problem. The next, in unsupervised learning, this type of learning can be used to solve the association and clustering problems. Okay, association problem basically involves the discovering and patterns in the data, finding in co-occurrence of samples. Okay, the classical example of association mining is, okay, the relationship between the bread and jam. Okay, this is a classical example we can say. Okay, bread and jam. So people who tend to buy the bread and also tend to buy a jam. Okay, here it all about finding the association about the item that frequently co-occur or items are similar to each other. Okay, apart from association problem, unsupervised learning also deals with clustering and anonymous deduction problems. Clustering is used for the cases in targeting the marketing. Okay, for example, targeting some business plans. Okay, we can do all those things. You have to cluster this you have to cluster these customers based on the criteria, some criteria. We will be setting some criteria. Okay, based on that we can do it. Okay, and some similarities. Okay, digital ad works. Okay, use the clustering technique to cluster the potential buyers into the different categories based on their interest and their intent to anonymous deduction. On the other hand, use the track the unusual activities. The example is the credit card fraud detection. Okay, this is the classical example for used in the anonymous detection. Okay, and finally we have a reinforcement learning. Okay, in the reinforcement learning, as the figure indicates, okay, this doesn't have any data. Okay, it should start from somewhere. Okay, it need to learn, okay, where to go, and finally it needs to reach out here to getting the final reward point. Okay, the basic difference is, okay, basic difference between the supervised, unsupervised, and reinforcement learning is the input itself depends on actions. The total input is, okay, depends on the actions. For example, it starts here. Okay, it may go here, and again it will come back, and again it will go to the state in this path. Okay, it's purely based on the actions. The next one, the next parameter is the type of the data. Okay, what kind of data we are going to perform. Okay, in the machine supervised, unsupervised, and reinforcement learning. Okay, in supervised learning, okay, the machine will provide with the label data. As I said earlier, the machine will provide with both the input and as well as output data. Both will be labeled. Okay, here the figure indicates, okay, the input. This is the input. Okay, the cat. Okay, the cat image is there. The label is also available here. Okay, cat. It is fed into the algorithm. Okay, the machine learning algorithm. Okay, supervised learning algorithm, and it is classifying, okay, whether it is a dog image or cat image. Okay, because we will be we are training it as much as possible. Okay, because we have a label. Okay, so finally where it will go to the classify into the cat image. Okay, on the other hand, you can see unsupervised learning. In unsupervised learning, there is no label data. Okay, the same image. Okay, the dog and cat. Okay, both are going to cluster. Okay, cluster in different factors. Okay, here there is no input label, there is no output label. Okay, here the algorithm needs to learn by itself. Okay, and find out, okay, whether this pattern is, okay, is for a cat or dog. Then finally it will be clustered into the cat, either cat or dog. Okay, and the final one is the reinforcement learning. There is no predefined data. Okay, there is no predefined, as I said earlier, there is no data at all. Okay, based on the agent action, okay, it will get some data. Okay, it will get some data. That is, the actions are recorded in the form of matrix. Okay, it will be formed everything in the matrix. Okay, for example, the action is state is going to state 1 to state 2. All the data will be stored into the matrices. Why it is? Okay, because it can be it can store everything. Finally it will reuse for next move. Okay, for example, okay, if we remove to the state 1, okay, it will not go to the further state, so it will store everything in the memory. Okay, so that the agent can explore the environment and collect the data which can be be being used to get the output exactly within the time. Okay, the agent will get all the data from the scratch. Okay, there is no data, even a single data in that. Okay, it should get from the scratch. And the next parameter is training. Yes, in supervised learning, the training phase is well defined and very explicit actually, because both the input and output both are labeled. Okay, the machine is fed into with the training data where both the input and output labeled. Only the thing is mapped to input to output. Okay, only the best thing we need to do is mapping to input to output. Okay, if I'm giving input some image, it should be mapped with the output image. That's it. That is the thing we are going to do. And the second one, okay, unsupervised learning. As I said earlier, there is no supervision at all. Okay, the training phase is too large, because in the machine learning is given the input data without any label, right? So that it needs to learn from its patterns. Okay, it takes some time. Okay, and its own, there is no supervision and no mentor is here. Okay, it should learn from patterns, and it will be providing the output to the user. Okay, and the final one is reinforcement learning. Here there is no supervision, as the figure indicates. Okay, if the football is coming to the agent, okay, it needs to think what to do. Okay, first it will do some action states. Okay, it will take and throw, and it will hit. Okay, many things it can perform. Okay, until it will get the reward points. And the next parameter is aim. Okay, in supervised learning, aim is to forecast an outcomes. Okay, this is the basic aim of all the machine learning type. But the whole supervised learning process is built in such a way that it can directly gives you predicted output, because supervised learning have a very well defined training and testing phase. Okay, that is, we will be getting high accuracy. Okay, we will be getting high accuracy in the case of supervised learning. When it comes to unsupervised learning, is all about to discover the patterns to interact with the useful insights. Now the algorithm is only fed into the input, and it has to find out the way to get the output by finding the trends in the association on the data. And the final one is, okay, the reinforcement learning. The agent here is like a human child, for example. Okay, here is a human child. Okay, when it gives human child, okay, have a baby is look a world. For example, if you just think this agent is a baby. Okay, we need to think, okay, how the baby will look the world. Initially the baby doesn't have any idea about the world or environment. Okay, let's say environment. Okay, but as it explores the environment by starting, okay, learning things one by one, okay, it will learn the experience. Okay, it will learn the experience, and it will act according to the experiences. Okay, and the next parameter is approach. When it comes to the supervised learning, it quite simple procedure, because as I mentioned earlier, it maps the known input to the known output simply. Okay, maps the label input to the known output. Okay, the label data is given to the training phase, and the algorithm is supervised learning algorithm is fed into the testing data. Then finally we will be getting the known output. Okay, there is no complicated procedure involved in the supervised learning. In case unsupervised learning, okay, the algorithm has to find the patterns in the data and discover the output. It has to explore the data until it reaches the output. Okay, it has to explore it. It will work. It takes much time, okay, to provide the output. Okay, the approach followed by unsupervised is next is reinforcement learning. Okay, reinforcement learning is simple word. Okay, we can follow the trial and error method, because the agent starts working on the environment. Okay, trial and error method only. Okay, it will start move from the agent state 1 to state 2. It is a trial and error method. Okay, it may hit or it may lose. Okay, if it is hit, it will go to the reward state, or else it will go to the punishment state. The next parameter is the output feedback. Okay, in the supervised learning, okay, direct feedback is enabled. Okay, because we'll be having known input and known output. We will be getting the output correctly. Okay, the machine is trained with the labeled input and output. In unsupervised learning, there is no feedback mechanism is followed. Okay, there is no feedback at all, because we will be providing unknown data. Okay, to the algorithm. Okay, we will be providing the unknown output only. Okay, there is no labeled data at all. Okay. Now, in the reinforcement learning, the feedback is in the form of rewards. Okay, we can add one more thing, the punishment also. Okay, the rewards and punishment. When the agent takes the suitable action, it will get the corresponding rewards or corresponding punishment. Okay, based on their action. Okay. Next. The next parameter is popular algorithms involved in the supervised, unsupervised, and reinforcement learning. Okay, these are some of the supervised learning algorithms which are popular: linear regression, logistic regression, support vector machine, k nearest neighbor, random forest. As ma'am told earlier, okay, some of the surveys, okay, they have finally they got few like few outputs. Okay, the standard algorithm is SVM and followed by NN, KNN. Okay, these are the standard algorithms we are using many industries. Okay, in case of unsupervised learning, we will be using K-means algorithm, a priori, and C-means. And finally, in reinforcement learning, okay, it's a upcoming area. We will be having two standard algorithms. First one is Q learning, and the second one is the SARSA. The final one, the application. Okay, few applications, okay, are very popular in terms of machine learning. Okay, we will be categorizing few only in terms of supervised, unsupervised, and machine reinforcement learning. Sorry. In supervised learning is widely used in business sector. Okay, as I said earlier, it's widely used in business sector to predicting the sales profit and forecasting some process. Okay, in unsupervised learning, it is well good in used in a recommender system, product or movie recommendation, product recommendation. Okay, they are using many things. Okay, in terms of recommendations. Okay, and anonymous detections. In RL, okay, self-driving cars and video games. Most of the AI games, okay, it's based on only reinforcement learning. And next, we'll be having 5 different use cases, okay, based on our algorithms. The first use case given here is bank credit data set. Okay, this is a bank credit data set. Okay, we have given only the snapshot. Okay, here you have make a decision about whether to approve the loan of an applicant based on his profile history. Okay, he is having some profile history in the bank. Okay, based on that we are going to check whether he is eligible for a loan or not. Okay, this is the task we are going to do in the use case. Okay, here you can see the information about, okay, some account balance. Okay, for example, first starting with account balance and the duration of credit month, payment status, and finally we can say occupation and age in years. Okay, these are the some of the parameters, okay, which they are going to consider to release the loan. And hence we use the supervised learning algorithm. Okay, here we are going to use the supervised learning algorithm. We are using k nearest neighbor. Okay, we are going to do k nearest neighbor algorithm. Okay, based on that we are going to give categorize it. Okay, whether he is eligible to eligible for loan or not. Okay, approve or reject. Next, our second use case is, okay, here we are going to establish the mathematical distance as a function of speed. So you can predict the distance when only the speed of the car is known. Okay, this is the thing we are going to do. Okay, here we are having only 2 parameters. Okay, speed and distance. Okay, here we are going to use the same supervised learning algorithm, that is linear regression. Okay, these are the continuous values. Okay, if we enter this, okay, we will be getting the prediction. Okay, prediction of the distance when the speed of the car is given. Okay, and the next use case, our next use case is the cluster. Okay, to cluster the set of movies as either good or average based on their social media outreach. Okay, this is the data set. Okay, this is the data set which is downloaded from the social media thing. Okay, for a movie data set. Okay, here we are going to use cluster. Okay, you can mention the keyword cluster. Cluster comes under the category of unsupervised learning. Okay, this use case fall under the unsupervised learning. Okay, here we are going to use k-means algorithm. Okay, in unsupervised we saw k-means, c-means. Okay, here we are using k-means algorithm to cluster the movies into the popular or non-popular movies. The next use case is to perform the market basket analysis by finding the association between the items bought at the grocery store. Okay, here you can see the keyword association. This means that association problem. Okay, association problem falls under the category of unsupervised learning. Yes. Okay, hence we are using the a priori algorithm to find out the product association. For example, product A associated with product B. Okay, this is a simple mechanism they are using. Okay, and the final use case. Okay, this is our final use case. Okay, this is obviously it will be fall under the reinforcement learning. Okay, in this use case we are going to check place an agent in any one of the room. Okay, the room numbers are given like in such a way that 0, 1, 2, 3, and 4, and the goal is to reach outside of the building room number 5. Okay, here we need to start with the 0. The agent needs to start with the 0, and it needs to reach the room out. Okay, room number 5. Okay, for that we are going to use queue learning algorithm. Okay, what it will do, it will come here. Okay, it may go this side and it may go this side. Okay, it will go out of this side. Okay, it needs to go this path. Okay, or else it needs to go 3, 1, and 5, or else it may go 3, 2, again it will come. Okay, there are a number of possibilities, based on the agent action. Okay, we will be reaching the room number 5. Here you can see different types of applications are used in the supervised, unsupervised, and reinforcement learning. This machine learning, okay, as we know, supervised, unsupervised, and reinforcement, we know the categories: classification and regression. Okay, in the classification you can see, okay, the classification: image classification, customer retention, diagnostic, and identity fraud detection. Okay, these are the some of the popular applications are used under the unsupervised learning. In case of regression, okay, there are past forecasting. Okay, the major thing is forecasting, weather forecasting and market forecasting, estimating the life expectancy and population growth prediction. Okay, these are the some of the applications we are using in real time in terms of supervised learning. Okay, as considered in the unsupervised learning, okay, we'll be having clustering. Okay, clustering, okay, the base, the primary thing, okay, we are using is a recommender system, customer segmentation, and targeted marketing. In dimensionality direction, we will be using feature elimination, feature selection, big data visualization, and meaningful compression, structure discovery. These are the some of the application we are using with respect to unsupervised learning. Okay, finally we will be having reinforcement learning. Okay, as I said earlier, gaming AI, this is the industry where we are using most of the reinforcement learning and robot navigation. Okay, most of the companies, they are using reinforcement learning for robot navigations. Next, the predictive modeling in healthcare, challenges and opportunities. Okay, the task, it is the most important to select the best analytic tool. Okay, that is the most important challenging task. Okay, when you are working with the predicting modeling in healthcare sector. Okay, because each and every model will give different outputs. For example, I will be using KNN algorithm, I will be giving some different output. I will be someone have used some other algorithms, supervised learning algorithms with SBM or some other thing. Okay, it will be giving some different outputs. Okay, because we need to select, okay, best algorithm, best product, or best algorithm, okay, analytical tool, okay, for our industry. Okay, that is the major challenge. The second one is technology adoption. Okay, the technology adoption, every day, each and every day we will be having, the world is giving more and more technology. Okay, some technology will release in the form of healthcare or some other sector, real estate. Okay, we will be having more technology adoption. The healthcare sector should adopt, okay, in terms of technology. Okay, that is one more challenge. For example, if the company is using Accenture, if the company is using some predictive algorithms, okay, using some technology. Okay, the world is having some other, they need to adapt to some other algorithms. Okay, and then third one is lack of participation of data scientists. Yes, this is also one of the factor, one of the challenge. Okay, the participation along with the data scientists is more important. Okay, for example, if they are well experienced data scientists, they could know, okay, what are the possibilities. Okay, what are the possibilities, pros and cons. Okay, if they are naive, if they're naive in nature, okay, we are not supposed to expect the performance of the model. Okay, then what are the opportunities we are having? Okay, obviously we are having a numerous n number of opportunities in terms of research. Okay, we can do many research in healthcare sector. Okay, the second one is addressing the needs of clinicians in their workflow. Okay, they will be having some workflow to go with the healthcare sector. Okay, we can provide more possible ways to address their workflow. Okay, then the last one is interdisciplinary. Okay, interdisciplinary, many of them they are thinking that, okay, they can medicine, bioinformatics, as well as the computer science engineering students, they can go with the some predictive techniques. Okay, it's not like that. Okay, we can go many interdisciplinary design teams to improve our models performance. Yeah. Yeah, this image, this is the organization current and project predictive analytic use. Okay, this is the image. This image shows that the predictive analytic adoption increased 13 points over the past year. Okay, past year 2019 to 2020. In 2019, the current predictive analytic uses 60 percentage. Yes, 60 percentage jumped with a significant 13 percentage year by year over year increase from the 2018. From 2018 to 2019, there is a 13 point is increased. Okay, and 6 point increase from the 2017. Okay, the drastic change, 6 points from 2017 to 2018, 13 points to 13 points to 2018 to 2019. Okay, it's highly improving. Okay, each and every year it's improving. Okay, if you take past 3 years, okay, we can say, okay, 19 points it's improved, 19 points and improved from 2016 to 2019. Yes, the predictive analytics in healthcare trends. Poised to reshape for the healthcare industry by achieving the triple aim. Okay, what is the aim we are going to do? Okay, aim to improve the patient's outcomes, quality of the core, and lower costs. But how are executive actually using the predictive analytics, and thus it helps to discover the insights efficiently with respect to the healthcare sectors. Okay, to answer this question, the Society of the Accreditation conducted the annual survey. Okay, this is the annual survey which is conducted by the society. Okay, SEA. Okay, we will be having 60% of payers and providers, and 16% of providers cites too much of data. Okay, they are quoting that too much of data. Okay, and 23% they are telling that data visualization. Okay, 16% they are telling about machine learning. And the industry, okay, the overall the industry, okay, this is the graph. This shows, okay, the overall industry. Okay, just talking about the predictive analytics, they are investing in it. Okay, they are investing in it over a period of time. Okay, from 2010 to 2020. Okay, they will be checking it. Okay, the survey of 60% of players and providers, okay, expect to dedicate, okay, 60%, this is the last graph. Okay, 15% or more, okay, spending, okay, predictive analytics, and they are anticipating that the investment will pay off nearly 2/3 of executives. That means 61%, okay, totally 61% to forecast the predictive analytics will save their organization. Okay, will save their organization totally 15% or more. It will save their organizations within the period of 10 years. And this is the healthcare executive anticipate the future change predictive analytics to reduce the cost. Both the payers and providers execute the task of the future in the predictive analytics is data visualization. Okay, 23% data visualization, and 5 points increased from the 2018. Okay, 5 points it increased from 2018. Other anticipated improvements include a refining data collections. Okay, 18% they are telling it refining the data collection, and as I said earlier, 60% of machine learning algorithm, and 12% they are indicating that investment in the people with necessary expertise. Okay, data science or biometric informatics or computer science students or researchers. Okay, all those things. 12% they are expecting that the process automation, and 10% they are looking for health and wearables, and 8% they are not sure, okay, what they need to provide, okay, when they are collecting the survey, and 1% they are in the under the category of others. Okay, let me go to the demo. Okay, I will be showing two different demos. Okay, both are in classification. The first one is breast cancer classification, and the second one is DNA classifications. Okay. Okay, the purpose of building and analyzing the machine learning classifiers. Okay, here in this tool, I'm going to show you. Okay, I'm going to use two different machine learning classifiers. Okay, in these two different machine learning classifiers, what I'm going to do, okay, is to determine which classifier model is most accurately diagnose the patients with the breast cancer, defined as a person who encompasses a malignant tumor. Okay, along with that, I have used a breast cancer data set. Okay, which is available in the internet. Okay, the basic motivation of this thing is, okay, it's going to check, okay, learning about the effective systems to measure the accurate diagnostic patients and how to find the early signs of cancer. Okay, what are the early signs of cancer based on the 32 attributes. Okay, in this data set, we will be having 32 different data sets. Sorry, 32 different futures. Okay, from that we are going to learn, okay, what are the futures are depends on the cancer. Okay, based on that we can find out the treatment. We can go with the treatment, better treatment. Okay, yes. First, initially, all the algorithms starts with importing some packages. Okay, here I have imported some of the packages. Okay, imports is SAIPY, NumPy. These are the packages. SKI learn. Okay, you can download it from that, or else you can use this keywords. Okay, imports is import SAIPY, NumPy, pandas. Okay, sklearn to get the machine learning package, cborn for graphs. Okay, these are the packages I have imported. Okay, this complete thing is done with the colab. Okay, the complete execution is done with the colab using Python programming. And the second thing, okay, this is for visualizing the data set. Okay, this is our data set, okay, which is in the form of Excel CSV file. Okay, these are the some of the features: ID, diagnose, radius measure, and texture measure, parameter measure. Okay, these are the totally 32 features are available in that. Okay, these are the some of the attribute information. The first one is ID number. Okay, the patient ID number. Okay, the second one is diagnosis, malignant or benign. Okay, which fall under the category M or N. Okay, I have listed out only the 19 samples. Okay, and the 32. Okay, totally 32 was there. Okay, the 10 real valued features. Okay, the remaining 10 real valued features are listed here. Okay, finally, okay, I have imported more packages, okay, sub packages, okay, to different arguments following libraries for that to classify our reports and showing some plots, okay, using some classifiers. Okay, for that I have imported some of the packages. Okay, the first initial thing what we need to do, first we need to work with input warnings. Okay, when you are running the program, okay, if many warnings will be able to you can see in the warnings section. Okay, it may contains 50 or 60 lines. Okay, to avoid that, okay, I'm using warnings dot filter warnings ignore. Okay, I'm ignoring what are the warnings I'm getting into the execution time. Okay, for that I'm using this. Okay, this is an optional one. Okay, you can use or not. Okay, the second one is load the data set. As already we have our data set, we are going to perform the prediction of classifying the breast cancer based on this data set only. Okay, df is a variable name. Okay, we are going to store our data set under the df. Okay, pd.read csv. Okay, we are going to read the csv file. Okay, this is the location content slash sample data slash breast cancer data.csv. Okay, by using this line, okay, we are reading the data set. Okay, then after reading it, okay, we need to cross verify whether the data, okay, df, whether the df contains the actual data or not. Okay, for that I'm using df.head. Okay, if you are giving this df.head, okay, it will give you the header. Okay, what are the header we are having in the Excel file along with 5 rows. Okay, along with 5 rows starting from 0 to 4. Okay, if you want to show all the data, for example, you will be having 768 rows. Okay, you can give df.head 768 here. Okay, then you will be having the listed all the data. Okay, if you are giving, this is a standard thing. df.head means, okay, it will give you the 5 rows, first 5 rows. Next, once the data is fed into the system, okay, then we need to do pre-processing the data. Okay, in pre-processing data, what we are going to do, we are going to check whether we are having a missing value or not in the Excel file. Okay, for that I am importing the missing number. Okay, visualizing the missing pattern. Okay, these are the features. Okay, these are the titles which we have in the Excel side, right? ID, diagnosis, radius, mean, texture, mean. Okay, all those things. Okay, here missing number dot matrix, we are going to build a matrix. Okay, how we are going to build the matrix is based on the df. Okay, because all the data are stored into the variable name as df. And figure size, this figure size indicates the total figure. Okay, the size of the figure. Okay, matrix figure 20,2. The 20,2 indicates the 20 indicates the x-axis value and 2 indicates the y-axis value. Okay, if you want a bigger image, okay, you can change the values 30 or 20, the 10 or 5. Okay, like that you can change here. Okay, the inference of this graph, inference of this matrix is, okay, here you can see all the features. Okay, up to here. Okay, fractal dimension worst, okay, you will be having the data values. Okay, here you can see unnamed 32, there is no values at all. Okay, there is a missing values here. Okay, we have found out it. Okay, then we need to delete the complete row unnamed 32. For that, I'm using delete df, because we have stored everything in the variable name df unnamed 32. That is a column name. Okay, that is a column name we are having. Okay, and next one, I'm going to delete the id as well. Okay, the id is not going to be useful for me, so that's why I'm going to delete the id. Okay, delete df of id. I have deleted two columns. First one is id and second one is unnamed 32. Now I have to re-verify, okay, whether the ID and as well as unnamed 32 is available in the df or not. Okay, for that's why I have rerun that value df.head. Okay, what it will do, it will give you 5 rows. Okay, here you can see there is no id. Here you can see there is a id. Okay, here you can see there is no id. Here it starts with diagnosis, radius, mean, texture, mean, like that. Okay, then one hot columns. Okay, next one hot columns. So what we are going to do, we are going to convert the columns into list. Okay, one hot columns, it will do what, it will convert the columns into this df columns dot to list. Okay, here everything, diagonals, radius, mean, texture, mean, perimeter, mean, everything is in the form of cluster. Okay, sorry, the form of columns. Okay, here we need to convert it into list. Okay, now print one columns. Okay, here you can have a list. Okay, the within the square bracket. Okay, diagnosis one list, radius, mean, texture, mean, everything will be separated. Right, we have done. Next, what one-hot encoder will allow us to represent of categorical data to be more expressive, because more expressive. Many of the machine learning algorithms cannot work with the categorical data directly. So the categories must be converted into numbers. So that's why we are using that one-hot encodings. Okay, here get the dummy values. Here you can see some of the values are M, 17.99, 10.38, like that. Okay, here you can see the difference. Okay, 0, 1, 0, 1, 0, 1, like that you will be having. Okay, how it will done? Okay, data binary encoder is equal to pd.get dummies. Okay, it will give you the get dummy values for each and every features available in the data sets, in the columns. Okay, df, okay, because all the values are stored under the df columns is equal to one hot columns. That is the thing we are going to use. Finally, I'm going to print data bin encoding dot head of 5. Okay, I have given 5 here. So you will be having the output like this. Okay, 5 rows and 1, 5, 3, 4, 2 columns. Okay, previously it is 762 columns. Previously it was 762 columns. It will be 762 columns. Okay, it will be converted actually. Okay, it takes a column which have the category data which has been label encoded. Okay, between zeros and ones. Okay, easily we can access it. Okay, easily we can access the data. Next, data concatenate encoding. Okay, the dataset concatenate encoding df dot apply. Okay, label encoder. What label encoder it will do? Label encoder, it will assign some normalized values. Okay, because zeros and ones we can't work with further. Okay, to transform the labels, okay, we are going to use the label encoder. Okay, here you can see, okay, zeros and one, diagnosis zeros and one will be there. Here all the ones and zeros, it will be transformed into some random values, normalized values. Okay, here you can see, okay, print df output. Okay, 0, 1, 2, 3. Okay, column a b c d a d d e f will be there. Okay, if we are applying df apply label encoder fit transform, okay, here you can see, okay, the abcd values will be changed into some other normalized values, 0, 1, 2, 1. Okay, here d is normalized into 0, 0, 1, 2. Okay, like that we are going to normalize it. Finally, I'm going to check the data. Okay, dataset concatenate encoding, because the after applying the label encoding, we have stored all the values under the variable name dataset concatenate encoding. Okay, dataset concatenate encoding dot head. Okay, it will give you the 5 values, 5 rows. Here you can see the difference between the diagnosis. Okay, diagnosis beligant and malignant. Okay, beligant and malignant. Okay, here you can see b and m. Okay, here you can see 0 and 1. Okay, after using this dataset concatenate encoding, this is before using. Okay, before using b and m. Okay, the dependent variable is b and m. Here the dependent variable is 0 and 1. Okay, this is a plot just for our reference. Okay, and next, now only we are going to perform the prediction. Okay, prediction. process. Okay, create x and y values, a dependent variable as well as independent variable. Okay, we are going to split the data. Okay, x is equal to np.array. Okay, the final data set is stored under the variable name dataset concatenate in. Okay, drop diagnosis. Okay, drop diagnosis means, okay, the all the diagnosis column alone, okay, it will move off. Okay, it will delete. Okay, the remaining features are considered as an x parameter. Okay, drop. Okay, so that's why we have used drop diagnosis comma 1. Okay, y np.array dataset concatenate diagnosis. Okay, y, that is independent variable, will be fall under y. Okay, this category, this parameter falls under only one column, it is diagnosis column. Okay, see here, now I am printing the x value. I'm printing the x value. Okay, it will show you 371 455. Okay, you can see 371 455. What are the values we'll be having? That will be here. Okay, print x value and print y value. Print y value will be having only the parameter diagnosis. Diagnosis which will be having only the two parameters, two values, ones and zeros. Okay, this is the y value. Okay, next we are going to splitting the train dataset and test dataset. Okay, you can go train dataset, test dataset in three parallel method. Okay, you can go with 60-40, 70-30, or 80-20. Okay, here we have used 80-20 ratio. Here x train, x test, y train, y test. Okay, these are the four values we are going to find out. Okay, based on the training test split x comma y, because we are having x parameter values as well as y parameter values. What is the test size? 0.2, which means 20% is considered as a test size and 80% is considered as a train size. Okay, print x train. Okay, train x train. Okay, which contains these many values. Okay, these many values. This dot 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 includes many values will be represented. Okay, this is the final value. This is the y train. Okay, y train, always y values will be having zeros and ones. Okay, y train values. And finally x test values, which will be having 20% from the data set. Y test values, which will be having 20% from the data set. Okay, finally we are going to perform the model. Okay, define the models to train. Okay, here creating an empty model for KNN. Okay, here I have created an empty list. Okay, empty list for models. Okay, we have used two models. The first one is KNN and the second one is SVM. Okay, the first one KNN. Okay, k nearest neighbor. Here what we have to do, first one, neighbor, we need to assign the neighbor values. Okay, it depends on you. We can assign 2 more, 3 or 5. Okay, k nearest neighbor values, you can assign it. And the second one is model that append SVM. Okay, and evaluating the each model in terms. Okay, here we are doing both the models in the for loop. Okay, here we are doing both the models in the for loop, so that's why we have used for loop. Before that, we are storing all the results in the list and names. Names means what is the SVM or KNN. Okay, both will be stored under the list names. For name models in model, okay, already we have models. Okay, models, what are the models we are having appended? KNN and SVM. Okay, model. Okay, this model indicates, okay, starts first, it will start name and model. First model, what it will do, we will train the model. Okay, model dot x train and y train. For training we need x value and y value, x train and y train value. Next is predictions. How we are going to predict the model? Based on the x test. Okay, because we are going to give x test value. Okay, the predictions will be based on x test. Okay, then finally print the name. Okay, which algorithm we are performing? Print the name, print the accuracy score. Accuracy will be considered in the y test value as well as the predicted. Okay, based on the x test value we have predicted, right? Okay, based on that we are performing the accuracy, and finally we are printing the classification report. Okay, the classification reports in terms of y test and predictions. Okay. Okay, these are the output we have received. Okay, the KNN, the accuracy comes under 0.9649 something. Okay, the SVM we have 97.3. Okay, we can round, or we can multiply into 100. Okay, 96 into 97. Okay, the SVM is better. Okay, if you are comparing with these two, the SVM is performed better. Okay, these are some of the measures. Okay, classification report means you will be getting the precision, recall, F1 score. Okay, these are some of the parameters you have to print, and you can check the accuracy. Okay, because the performance of the model is purely in terms of accuracy. Okay, we can measure the accuracy mathematically by using precision, recall, F1 score support. Let us say the accuracy can be TP plus TN divided by TP plus TN plus, and precision can calculate based on TP plus FP, and recall we can get TP by TP plus FN, and FN score we can calculate 2 into precision into recall divided by precision plus recall. Okay, these are the some of the values we will be having, and this macro average and micro average. Okay, this is the macro average, micro average. Okay, this is the accuracy. Okay, whatever the values you got here, this will be reflected here. Okay, with 2 decimal points. Okay, the accuracy here 97 points. Okay, this 0 and 1. Okay, this is for malignant and benign. Okay, because we will be having 2 classification, right? This is the precision of 0 and this is the precision of 1. Okay, this macro average and weighted average. Okay, the macro average says the functions to compute. Okay, the model. Okay, compute the model each label and returns the average without considering the proposition for each labels in the data set. Okay, for example, we will be having radius measure. See here, radius mean, texture mean, perimeter mean. Okay, all those things. Okay, it will not consider the proposition of each label in the data set. But whereas in weighted average, okay, it will consider the average of the proportion. Okay, this is the difference between the macro average and weighted average. And this is my next demo, classifying the DNS sequences. Here, the same. Okay, the first initially we have to start the importing the packages. Okay, import sys numpy, sklet, learn, pandas. Okay, all those things I have imported. And the second thing I have checked with the version which I'm working, and GCC, numpy, sklearn, and pandas. Okay, what are the versions? Okay, I'm working it. I'm just re-ensuring it. Okay, and the second thing, I have to upload the data. Yes, here I have used, okay, use a molecular biology, okay, data set. Okay, use a molecular biology data set. It's purely gene sequence. Okay, I have not uploaded in the form of CSV. I have taken the data set from the particular URL, okay, which is in achieve.ics.uci.edu. Okay, in that you will be having ML machine learning database, molecular biology, promoter gene sequence data. Okay, that is the data set. I'm going to get the dataset from the URL, okay, and okay, that value is in the form of some XML format. Okay, for that I'm using names. Okay, I'm creating names class ID sequence, because in Excel we can have the title. Okay, title, for example, diagnosis, ID, like that. Okay, here in this dataset there is no column. Okay, there is no column for the header. Okay, for that's why I have created this column names is equal to class ID sequence. Okay, then data is equal to p.read.csv. Okay, your names is equal to name. Then what I have done, I have imported that CSV file. Data head is equal to, okay, as I said earlier, okay, it will show you the 5 rows, okay, which contains class, ID, and sequence. Here you can see the sequence, the gene sequences like /t tag. Okay, there is some other slash. Okay, here there is some other slash like that. Okay, for that's why we have to check. Okay, for each column the data frame is called as series, because all the values are in the form of series. Okay, make each column. Okay, first I'm allocate the data. Okay, plus class. Okay, I have taken only the class variable. Class is equal to data location. Okay, colon comma class. Okay, which means, okay, it will take only the class values. Okay, it will be stored in the class. Okay, I'm printing class colon 5. Okay, I'm printing first 5 values 0 to 4. Okay, I'm checking it out and generating the DNA sequences. Now I have to generate the DNA sequences because I will be having the sequence like /TT/AA/GG, like that. Okay, I have to do the pre-processing, so that's why I have to create a DNA sequences in my format. Okay, for that's why sequence is equal to list of data location. Okay, sequence. I'm taking only the sequence column. Okay, remaining columns class and ID I'm removing it off. Okay, I'm creating a data set. For I sequence in enumerate the sequence. Okay, this is the for loop we are going to use to split the individual nucleotides. Okay, individual nucleotide /TTT, like that. Okay, we'll be having, right. Okay, we are splitting into the nucleotides, removing the slash characters, tab characters. Okay, for that's why nucleotides is equal to list of sequence. What are the sequence we are having, that will be available in the list. Okay, nucleotides is equal to x for x in nucleotides. If x is equal to x, x is a value, okay, which we are going to give. X not is equal to slash t, we are checking it. Okay, if it is there slash t, it will remove the slash. Okay, append the class assignment nucleotides, append class of I. Finally what it will do, it will append the I values, each and every values, like t, a, c, t, a, g, e, a, t, like that. Okay, to add the data set of I is equal to nucleotides. Okay, everything will be stored in the data set. Finally, it will be in the form of array. Okay, print the data set of 0 means, okay, it will give you only the 0th row. Okay, it will give you only the 0th row. To turn the data set into the pandas data frame, okay, I will be having all the data. Okay, previous screen you will be having only one row. Okay, the second one, turn the data set into pandas data frame. D frame is equal to PD data frame of data set. Here what I'm given, the data set, what are the data set I have collected, the data set I have given to and transforming into data frame. Okay, here you can see 0 to 105, here you can see 57, totally 58 rows and 106 columns. Okay, I have just printed for my perfect. Next, transpose the data frame. Okay, TF data frame to I am transposing into columns. Okay, so that's why DF is equal to data frame, because everything will be D frame dot transpose. Okay, which will be stored in the DF. Okay, as we see in the last demo. Okay, everything all the values we have used to store the variable name df. Okay, here the transpose function is used to transpose the index and columns. Okay, here you can see the difference. Okay, print df dot log. Okay, everything. Okay, we have not mentioned any columns and row values here. Okay, if you given colon, okay, it will take all the values. Okay, here you can see 106 into 58. Here you can see in the DFM 58 rows and 106 columns. For clarity, for better clarity, we are what I'm going to do. Okay, df dot rename columns is equal to 57. 57th column I am going to here now. 57th column is class column. Okay, plus 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 minus minus, like that we will be having, right? Okay, this is the value we are going to based on this we are going to classify our thing. Okay, gene expression, right? Okay, so that's why I am making this column name 57 into class. Okay, for that's why df dot rename columns is equal to 57 colon class in place is equal to true. Okay, finally I'm printing the same. Okay, print df dot I location of 5. Okay, 5 rows will be here. Okay, here you can see there are sorry there are a number of values here, right? Okay, all the values will be printed here. Next, yeah, we can implementing the algorithms. Okay, as we see earlier. Okay, we have worked with the dummy values, get dummy values, because we will be having a t t c c plus all those things. Okay, because we are going to work with the dummy values 0 and 1s. Okay, so that's why we are using get dummies numerical.df. This is the variable name where we are going to store all the values. PD.get dummies df, because all the data are stored under the variable name df. Okay, then I'm going to print numerical underscore df dot iloc of 5 means, okay, it will give you like that. Okay, this is the value zeros and ones. Okay, here you can see everything will be transformed into zeros and ones. Okay, next, df numerical df dot drop. Okay, here we have used columns, right? We have used columns, df drop columns, because we are going to use for namesake we are going to use the columns slash. Okay, plus minus, we will be having two categories, right? Minus and plus, the DNA sequences. Okay, numerical data columns column slash. Okay, here you can see, and rename the columns of class underscore plus, it will be a class. Okay, finally we will be having a class values 1 and zeros. Okay, rename the column plus, and finally I'm printing the same. Okay, each and every time I'm printing and I'm ensuring, okay, whether my line is executing properly or not. Okay, so that's why these many outputs. Okay, output screens. Okay, here use the model selection. Okay, here we are going to do the x and y. Okay, we are going to classify x values and y values. As we well aware of it, okay, we are having only three features: id and sorry, yeah, class id and sequence. Okay, that's it. Okay, here we are going to do only the class value is y axis. Okay, the remaining two values are in x axis. So that's why we have given x is equal to np dot array df dot drop class comma 1. Okay, we are dropping the class column. Okay, and the rest of the features are considered as an x value. The y value, okay, the y value is considered y value, the class value is considered as an y. Okay, I'm just printing the x value. X value contains zeros and ones. The y value, that is also contains zeros and ones. Right, now next I'm splitting the data into training and testing. Okay, here x train and y train, x train, y train, x test and y test. Okay, here model selection, train select, test split. Okay, here I have given 75-25. For a different purpose, I have given 75 and 25. Okay, test size is 25 percentage and train size is 75 percentage. Okay, here I have done printing the x train value, printing the y train value, printing the x test value, and printing the y test value. Right. Yes. Here, I'm going to work with the models. Okay, here you can see these many models I'm going to work. What are the models means? The k-nearest neighbor and Gaussian process, decision tree, random forest, neural network, ADA-boost, naive-based, SVM classifier, SVM RVF, SVM sigmoid. Okay, these are the classifiers I'm going to work, and I'm going to check the performance of each classifier. Okay, with respect to the DNA sequence data set. Okay, so classifiers is equal to, classifier is a list. Okay, I have created the classifiers. Okay, these are the classifiers. Okay, the list is end here. The nearest neighbor, we need to give the nearest neighbor value. Here I have given the nearest neighbor value is 3. Gaussian process classifier, that is Gaussian process classifier. This is the 1.0 and RPF. RPF value is the length. Okay, length to scale. Okay, that is initially everywhere we will be giving the radial bias value is 1.0 only. Okay, next the decision tree classifier. Okay, decision tree, as we know, maximum depth I have given is 5. Okay, you can see you can start with 2 or 3. Okay, then random forest. Random forest I have given maximum depth is 5, and estimators, you can give estimators, n number of estimators. Okay, 5 or 10. Okay, max number of features it should be selected is 1. And MLP classifier, the alpha. Okay, in this text we need to give the alpha value. The alpha value is standard alpha value is 1. I have given the same. And ADA boost, there is no specific constraint with ADA boost. And I have given Gaussian NB and SVM. In SVM, I have given 3 parameters: linear, RBF, and sigmoid. Both the 3 I have tested here. Okay, and here the models. Model zip names.classifiers. Okay, I have zipped all the names and classifier into the function. Okay, zip is a function. Okay, and result, I have stored all the result in the list and names. Okay, what are the names? SVM, KN, and what are the everything will be stored under the names. Okay, and for names. Okay, same like the previous session. Okay, I have executed a for loop. Okay, model fit, x train, y train, and prediction. I have done the prediction with the x test value and printing the values and printing the accuracy score and as well as the classification score. Okay, here you can see the classification accuracy score. Okay, is nearest neighbor is 0.77 percentage. Okay, as I said earlier, precision, recall, FN score, and support, everything will be presented here. Okay, next is Gaussian process, 0.88 percentage, decision tree 77, random forest 59, and neural network is 92, and AdaBoost is 85, naive Bayes is 92, and SVM classifier linear is 96, and SVM RPF we got accuracy by 77 percentage, and SVM sigmoid we got 44 percentage, which is the worst performance. Okay, from SVM sigmoid. Okay, here the overall performance which we have mentioned in the chart. Okay, as in the figure. Okay, you can see SVM linear is better performing than other classifiers. Okay, the highest score is 96, as followed by a naive Bayes 92. Okay, neural networks also having the same values. Okay, as my suggestion, okay, the predicting things, okay, will be having SVM and NN will work, and it will give you the best accuracy. Okay, and thank you.
If you have any questions, you can raise up now.
Hello.
Hello, ma'am. Ma'am, can you wind up, ma'am?
Yeah, yeah.
Thank you for the session, Mr. Balakrishnan, sir. So now, participants kindly fill up the attendance form. Thank you, ma'am.
Thank you, Kavita. I request all the participants to fill up the attendance form, and we'll meet tomorrow at 10 a.m. with the next session. Thank you all.
Thank you, ma'am.